Hello everyone, Namaste. This is Rohini Merugu from WIT Solapur. The topic is Stoke's Theorem Solution Part 2. I have explained Stoke's Theorem, which is LHS part in Part 1, and Stoke's Theorem Solution, which is RHS Part 2, will be explained in this video. While explaining this Stoke's Theorem solution, we have considered the cylindrical coordinate system. So, the topic is Stoke's Theorem solution part 2, cylindrical coordinates. Learning outcomes: at the end of this video, you will be able to apply Stoke's Theorem for a given vector field, and you will be able to verify Stoke's Theorem in cylindrical coordinate system. Stoke's Theorem, let us write it first. The theorem states that the closed line integral of h bar is equal to curl of h bar over the surface. Stoke's theorem, the theorem states that the surface integral of curl of a function, so curl of a function, surface integral over a surface bounded by a closed surface is equal to the line integral. So here you can see line integral of the particular vector function, the same vector should come here, particular vector function around the surface. On both sides there should be same field, and on one side there is a line field, on another side there is a surface field. So the line is related with surface integral, or line integral is related with surface integral. So let us look at the solution part. I am considering the RHS, which is closed curl of h bar dot ds bar. As there is a term curl, I need to first determine curl h bar in cylindrical coordinates. So curl h bar in generalized way can be written like this: 1 upon UVW, UAI bar, VAJ bar, WAK bar, dou by dou y, dou by dou j, and dou by dou k, UHI, VHJ, WHK. HI is the part along with the AI unit vector, HJ is the part along with AJ unit vector, HK is along with AK. What is UVW? UVW are the multipliers, IJK are the coordinates. So in different coordinate system, this curl h bar will be giving the different in different coordinate systems, we can write the curl h bar based on the multipliers as well as the coordinates. So what are the coordinates and the multipliers in the different coordinate systems? So let us recall it. So these are the multipliers in various coordinate systems. On this side there is the coordinate system. These are the coordinates which are written as IJK. These are the multipliers which are written as UVW. In Cartesian it is XYZ, multipliers are 1, 1, 1. In cylindrical, the coordinates are rho phi z and the multipliers are 1 rho 1. In spherical, it is r theta phi and multipliers are 1 r sin theta. So here, as the question is on cylindrical coordinate system, let us focus on the multipliers in cylindrical coordinate system. So I have focused on the cylindrical coordinate system where the coordinates or I, J, K are rho phi z respectively, and the multipliers U, V, W are 1 rho 1 respectively. So let us write this curl h bar in cylindrical coordinate system with these multipliers and these values here like this. So this is the generalized equation. In this equation, I can put UVW, that is 1 rho 1. After multiplication, it will result in rho. So it is 1 upon rho. UAI, VAJ, WAK will be A rho bar plus rho A phi bar and AZ bar. Dou by dou I will be dou by dou rho, and accordingly dou by dou phi and dou by dou z. So these coordinates have been put as IJK. UHI, VHZ, WHK will be H rho, rho h phi and hz. So this is what is called as curl in cylindrical coordinate system. Now this is a question where we want to solve the curl, we want to determine the curl in the cylindrical coordinate system for the given question. So h bar given to us is rho cos phi a rho plus z sin phi a z bar. Now in this curl equation, I need to put the value of h rho, h phi, hz. What is h rho, h phi, hz? That can be found out from the given equation. The part along with a rho bar is nothing but h rho. The part along with az bar is nothing but hz. So here I can write h rho is rho cos phi and hz is z sin phi, and the h phi, a term is not given here, so it is 0. So I can substitute these values in this equation. So I can put it like this: curl h bar is 1 upon rho. Everything else is same. Instead of h rho, I can put rho cos phi. Instead of h phi, here is h phi. Instead of h phi, I can put 0. Instead of hz, I can put z sin phi. So the curl in cylindrical coordinate system is written. We have substituted the values for the given particular question. Once this curl is known, or once the curl equation has been written, let us determine the actual value of curl h bar. For that, 1 upon rho is kept outside as it is. First of all, with respect to a rho bar, we have to multiply these two, dou by dou rho z sin phi minus dou by dou z 0. This term is written here. With respect to a phi bar, instead of a phi, there should be minus a phi. So with minus a phi bar, the multiplication of this middle should be left and others should be multiplied as dou by dou rho z sin phi minus dou by dou z rho cos phi. This term is written here. With respect to az bar, skip the last column and multiply these two, dou by dou rho into 0 minus dou by dou phi into rho cos phi. The term is written here. So these three terms will simplify. So when we simplify, we get dou by dou phi of z sin phi will result as z cos phi. This is derivative 0, so the term will be 0. With a phi bar, the terms is dou by dou rho z sin phi. Everything is constant with respect to rho. So the answer is 0. Here also with respect to z, there is no term of z. Again the answer is 0. In the third case, this term is 0, and in this term, there is a cos phi. Dou by dou phi of cos phi will result into minus sin phi. So minus rho sin phi. Continuing the same equation, here, the equation is written here. We can simplify it like this: z cos phi a rho bar, and everything else is 0. So last term, minus and minus is there, can be written as plus rho sin phi a z bar. So curl h bar, after simplification, I can multiply this 1 upon rho inside the bracket, 1 upon rho z cos phi a rho, plus here rho cancels out, so I get sin phi a z bar. Now I can find out curl h bar dot ds bar. So I got only curl h bar here, but I should now focus on ds bar. ds bar can be written in different coordinate systems, as well as for ds bar we should know in which plane we should write ds bar. So for that, in the question it is given that the current is in az bar direction, meaning we should consider the surface in the az bar direction. And to write the surface, let us recall the different surfaces written, different surfaces in cylindrical coordinate system. I have prepared the video on cylindrical coordinate system where I have explained how to write the differential surfaces. So the surface or area is multiplication of two lengths. This is a small section or a differential volume element of the cylinder. The surface or area is a vector quantity. It has three lengths as rho d phi. This is dz and this is d rho. So when I multiply these, like here and here, if I multiply these two lengths, the direction is outward a rho bar, which is rho d phi dz a rho bar. Similarly, there can be the surface in the opposite direction, minus a rho. When I multiply these two lengths, I'll be getting the surface in phi direction. When I multiply this curvature as well as this rho d rho length, I'll be getting as d rho d phi, and the direction is positive az. Similarly, there can be a surface in the negative az bar direction. In our case, for the given question, with the given surface is in az bar direction, so we should consider ds bar as d rho d phi az bar. So here I can consider the surface in AZ bar direction as ds bar is rho d rho d phi AZ bar, and this is the question which is carried forward. Only the thing here which I changed is the surface, which is rho d d phi AZ bar. Now as you can see, I have highlighted AZ bar which is self dot product will be resulting 1 because AZ dot AZ is 1. But here if you see the vector, it is A rho with AZ will result in 0. So the first term goes to be 0 and only left over is the second term, like integration of over the surface sine phi rho d phi. So there is a integration with respect to rho as well as phi. I can separate out the terms like this. I can write as rho d rho integration limit 0 to 2 sine phi d phi integration from 0 to 60 degrees. So this rho d rho can be written as rho square by 2, limits are 0 to 2. Sine phi, when I integrate, the result is minus cos phi, the limits are 0 to 60 degrees as per the question. So rho square by 2 is the term that is obtained, the limits are 0 to 2, so it is 4 minus 0 divided by 2, and here is minus cos 60 degree plus cos 0, so that thing is shown here, 4 minus 0 divided by 2 minus cos 60 degree plus cos 0. So 4 by 2 is 2, so cos 60 is 1 by 2, cos 0 is 1, so this will result in 1 by 2, and this is 2. So this 2 and 2 cancels out and I get RHS, which is surface integral of curl h bar dot ds bar as equal to 1 ampere. As you know that we have seen the previous video where the Stoke's theorem part 1, where I explained that closed integral of h bar dot dl bar has resulted in 1. In this video I have explained where Stoke's theorem part 2, here I have explained curl h bar dot ds bar, which is also giving me result 1 ampere. So I can say that LHS and RHS both are equal and equal to 1 amperes. So I can say here Stoke's theorem is verified. It can be verified for any vector field. The question asked was this: verify Stoke's theorem, and we have successfully verified the Stoke's theorem. And in case the question is asked to determine closed integral of h bar dot dl bar by using the Stoke's theorem. So this video will be the answer for it. I determined curl h bar. I have determined this curl h bar over the surface, which is 1 ampere, and the same I can equate this value, I can equate to closed integral of h bar dot dl bar. So this will be the answer, this video will be the answer for this second part. So finally for both the cases the answer is 1 amperes. These are the references used for preparing this video. Thank you.